So now, what I need you to remember from the other day is that B, if we're talking about rates, B is equal to 1 plus R. Okay, if it's an increase. If it is a decrease in value, B is going to be equal to 1 minus R. Well, here today we're going to learn a new formula because sometimes they don't tell you what the rate is. They just give you some information and you have to figure out the rate. So here is our formula for finding the rate. Looks kind of like slope, at least on the top half. The bottom's a little bit different. Okay, and it's not slope because it's not a linear function. So R is equal to y sub 2 minus y sub 1 over y sub 1. And we're going to use that formula in this problem about endangered species. And this problem is kind of a neat little problem. Okay, the table here at the right gives us the population for an Iberian lynx in 2003 and 2004. So if you'll notice, in 2003 there were only 150 worldwide. In 2004 there's only 120 worldwide. Okay, if it continues like this, it will eventually become extinct unless they take some, kind of measures to protect it. And that's put it on the endangered species list and all that kind of stuff. But this problem is all about when it might become extinct if they don't take any precautions. Okay. Oh dear, it's kind of interesting. When do you think it might be, Taylor? I mean, it decreased by 30 in 1 year.
So we're just supposed to count down every year?
Well, not really, because it's not going to decrease at the same rate every year.
We should. That's my point. That's why I said over here.
Yeah. And the thing is, if it decreased by 30 every year, it would be a linear function, and it's not. This is an exponential function, so it's going to be a curve, so the rate changes a little bit. Okay, Dylan, did you have a guess?
It's probably really wrong now. 23.
In 23 years or in 2023?
Oh shoot, no, I'm at 23 by 2023. I was reading the primary question.
Okay. Well, how about we just quit guessing and we'll just work through it, okay? All right, so for this problem, here's my formula. Hello. Oh, I didn't take any up today. We're missing a whole bunch of people because of the AP mock exam. But you are welcome to put it up there if you would like to.
No, I'm good.
Are you sure?
Wait, what was it?
Are you going to be able to leave it in your pocket?
Honestly, I went up there just to charge my phone.
Well, you're welcome to.
That's a good idea. Mine needs a little charge.
All right. So while a couple of you are charging your phones, let's get started on this problem.
No.
Yeah. Remember,
I got it. Yeah, I agreed.
if I'm going to write an exponential function in the form y equals a times b to the x, I need to know what a and b are. Well, a is your starting amount. So looking at the table they gave me, I started with 150. And they don't give me a b value, okay? But our b value, since it's decreasing, it's actually going to be 1 minus r, but they don't even tell me the rate. So what I have to do is I have to calculate the rate using the formula we looked at the top. Okay. So these amounts are your y values. The years are your x values. Okay? So my y values here. What is my second y value? 120. And what is my first y value? 150 over 150. So that gives me negative 30 over 150. What is that as a decimal? Negative 0.2. Because this is negative, that's why we're subtracting r. Okay? So technically it's 1 plus r because my r is a negative 0.2. Okay? So two ways of looking at it there. So my b value is only 0.8. What's wrong?
No, comprehended.
Yeah? So the two things I really need are this 150 and this 0.8. So my equation will look like this. Y equals 150 times 0.8 to the x. So now, this question asks, if this trend continues and the population is decreasing exponentially, how many Iberian lynx will there be in 2014? Well, here's the thing. This study started in 2003. So how many years is it to 2014? 11. So my x value will be 11. Okay? Because 2014 minus 2003, that is 11 years since this study started. So if I plug that in, how many will there be in 11 years? How many? 13? Well, now, can you have part of a lynx?
No.
No.
12.
So we're going to say there are 12.
That's my first guess, by the way.
Do you have to go
My second guess was 20.
where it started? Like,
Out how many years go right here. You have to take the year they're asking about. How far is that from the year this study started?
that's what I'm saying, like, could you do like 10 years instead of 11 if you did like 2004?
But 2004 is the second year of the study, so we want to go from when it started. Okay? So now, the guided question at the bottom says, if we use that exact same information for the model in problem 5, what will the world population of Iberian lynx be in 2020? So I'm going to use the exact same formula here. But what will my number of years be? 17, because I'm going to do 2020 minus 2003, and I get 17. So how many will there be in 2020? 3?
2.
What do you get? Is it 2 point something or is it 3 point something?
22,273 over 8,600.
It's 3. Okay. So guys, you can see that these exponential functions can be used for a lot of things. We talked about growth and decay the other day. We talked about interest rates. And today we talked about endangered species and the rate at which, their population is decreasing. Okay, so exponential functions are used for a whole lot. Okay, so all right, that is the end of section 7.1. We're going to take a look at a couple problems in the workbook, and then we may come back to 7.2 in a few minutes.